On a quiet September afternoon in 2013, a man named Martin Lindsay parked his Jaguar on a narrow street in the city of London. He walked away for less than an hour. When he came back, the left side of his car looked like it had melted in a house fire. The paint had bubbled. The wing mirror had warped into a puddle of plastic. And the strangest part? There was no fire, no explosion, no accident. Just sunlight, a clear sky, and a building. That building would soon earn a nickname that sounds almost like a joke, the Walkie-Talkie. But what happened on that street was not funny. It was physics turned into a weapon by accident by a group of the most respected architects in the world. This is the story of how a 37-story glass skyscraper in the heart of London became an accidental death ray. And the terrifying part is, almost nobody saw it coming until cars were already melting on the pavement. To understand how this happened, you have to go back to the drawing board, years before construction even started. In the early 2000s, London was racing to reshape its skyline. After decades of squat, boxy office towers, the city wanted icons, buildings that would end up on postcards. Architect Raphael Vignali was hired to design a tower at 20 Fenchurch Street, right in the historic financial district. And Vignali had a bold idea. Instead of a straight glass tower like most skyscrapers, he wanted something with a shape. A building that curved outward as it rose, wider at the top than at the bottom, like a barrel standing on its end. It was a striking decision. Most buildings taper inward near the top to reduce wind load and save materials. Vignali flipped that logic completely. The tower would bulge outward, giving it more usable floor space at the top, where the most expensive offices and restaurants would go. From certain angles, the building looked like a walkie-talkie radio standing upright. The name stuck instantly, and the press loved it. But here is the detail almost nobody outside the design team paid attention to. The building's south-facing wall wasn't just curved outward. It was concave. It curved inward like the inside of a bowl, or more precisely, like the inside of a satellite dish. And it was covered top to bottom in reflective glass panels. At the time, this seemed like a purely aesthetic choice. Nobody in the design meetings raised the alarm that they had just built one of the largest concave mirrors in Europe. Concave mirrors do something very specific. If you have ever used a magnifying glass to burn a leaf on a sunny day, you already understand the principle. A flat mirror just bounces light back in a scattered pattern. A concave mirror, curved inward, does something different. It takes parallel rays of sunlight hitting different points on its surface and bends them all toward a single point. That point is called the focal point. And when you concentrate the energy of thousands of square meters of sunlight into one small area, the temperature at that point can skyrocket far beyond what direct sunlight alone could ever produce. Now imagine that mirror isn't the size of a handheld magnifying glass. Imagine it's over 100 meters tall, made of thousands of panes of reflective glass, angled just precisely enough by accident to behave like a single curved lens. That's exactly what the south face of 20 Fenchurch Street had become. And nobody had run the calculations to check where that focal point would land. This is the invisible flaw. It wasn't a crack or a weak beam or a corroded bolt. It was a shape that looked beautiful on an architectural rendering and catastrophic in direct sunlight. Engineers later admitted that early design studies actually did flag a potential solar concentration issue. But somewhere between concept and construction, that warning got lost in the noise of budgets, deadlines, and design changes. A sunshade feature that was originally planned for the lower floors was reportedly removed or delayed during construction to cut costs and speed up the project. That missing shade would turn out to be the difference between a striking landmark and a genuine hazard. Construction finished in 2014. The building opened to praise. Critics loved the shape. Tenants moved in. Then summer arrived. The collapse in this story isn't a structural collapse. No steel bent, no concrete cracked. This is a different kind of disaster, a slow-motion one that revealed itself only when the sun hit a very specific angle at a very specific time of year for roughly 2 hours a day. It started small. In late August 2013, a barber named Eddie Cañete Rios noticed strange scorch marks on the front of his shop, right below the tower. Doormat fibers had curled and browned like they'd been under a heat lamp. He assumed it was some kind of chemical spill. Then a journalist parked his Jaguar nearby to interview him. When he came back outside, the side panel had partially melted, and the wing mirror had drooped into a shape nobody could explain with logic alone. Word spread fast. A local business owner grabbed an egg from his kitchen, cracked it onto the pavement in the hot zone, and it fried in front of a photographer within minutes. That image went viral almost instantly, because it turned an invisible physics problem into something everyone could understand in one glance. If a skyscraper can fry an egg on the street using nothing but reflected sunlight, something has gone seriously wrong with its design. Engineers rushed to the site with thermometers. What they measured was almost unbelievable. Temperatures on the pavement in the hot zone reportedly spiked past 90 degrees Celsius, hot enough to warp plastic and blister paint within minutes. For comparison, that's close to the temperature needed to boil water on a public street in the middle of London, caused entirely by a building's reflection. The geometry behind this was almost cruelly precise. Because the sun's angle in the sky changes throughout the year, the focal point of the building's curve only lined up with street level for a narrow window, roughly around midday, for about 2 hours, and only during a specific stretch of late summer when the sun sat at just the right elevation. Any higher in the sky, and the beam would land somewhere harmlessly on the building itself or above the street. Any lower, and it would miss the target completely. But for those 2 hours on the right days, the entire south face of the tower became a functioning solar furnace pointed directly at pedestrians, cars, and storefronts. This is what made the Flaw so hard to catch before construction. In a computer model, checked at the wrong time of day or the wrong month, everything might have looked perfectly safe. The danger only existed in a very narrow slice of time, hidden inside thousands of possible sun angles across a full year. It's the kind of mistake that doesn't show up until reality runs the simulation for you, in public, with real cars as the test subjects. Once the story broke, the response moved fast, because reputational damage in London's financial district moves faster than almost anything else. The building's developers issued a public apology. Workers were sent up to install temporary screens made of a material similar to scaffolding netting, aimed at breaking up the concentrated reflection before it reached the ground. A local restaurant even leaned into the chaos, offering to fry food using nothing but the tower's death ray as a bizarre publicity stunt. But temporary fixes were never going to be enough for a permanent skyscraper. Engineers went back to the design and installed a fixed sunshade system, sometimes described as a brise-soleil, essentially a set of horizontal fins mounted onto the lower floors of the building's south face. Think of it like putting sunglasses and a wide-brimmed hat on a mirror. The shade didn't change the building's shape. It couldn't, but it intercepted the sunlight before it ever reached the curved glass low enough to focus onto the street, breaking the beam before it could form. The fix worked. After the shading was installed, the extreme heat concentration at street level stopped being reported. The Walkie-Talkie kept its shape, kept its nickname, and kept operating as one of London's most recognizable buildings, just with an expensive lesson bolted onto its lower floors. The financial and reputational cost was steep. Reports at the time detailed multiple damage claims relating to melted car parts, and the incident became a case study taught in architecture and engineering programs worldwide. Not because anyone died, thankfully. Nobody was seriously hurt. But because it proved something unsettling. An entire team of world-class professionals, using advanced modeling software, still missed a basic optical principle that a child with a magnifying glass could have demonstrated in a backyard. That's the chilling part of this story. This wasn't a mistake caused by cutting corners on steel or ignoring safety codes. It was caused by beauty, by ambition, by a shape that looked stunning in a rendering and functioned like a weapon in reality. Somewhere in dozens of design meetings, across years of planning, nobody asked the one simple question that could have prevented all of it. What happens when the sun hits this exact curve at this exact angle on a clear day in August? It's a reminder that our most impressive engineering failures rarely come from a single dramatic explosion or collapse. Sometimes they come quietly, from geometry, from a shape nobody double-checked against something as old and predictable as the sun. A city built one of Europe's largest accidental mirrors in the middle of its financial district, and the world only found out when an egg fried on the sidewalk. If stories like this fascinate you, the hidden flaws behind history's biggest engineering disasters, the small oversights that snowball into chaos, then make sure you subscribe. There's a lot more dark engineering and logistics history waiting for you, and you won't want to miss what melts, cracks, or collapses next.